7th and 8th grade algebra students, welcome back. We're kind of in an extension section of chapter 4 on linear functions, and we're going to just take a little detour and learn about midpoints, calculating midpoints, and finding distances of segments that are on a coordinate plane. So let's go ahead and get started. I want you to mark this. This is going to be one of those standardized test kind of formulas. This is a typical algebra formula that you need to know and you need to be able to work with. And to calculate the midpoint, it's really simple. Midpoint is the name of an actual point that divides a segment into two equal pieces. So to find the x of your midpoint, you're going to take your two endpoints that are given, add the x's together in those endpoints, divide by 2. And then do the same thing for the y's. Take the y's in your endpoints and then add those together and divide them by 2. And that point, resulting point, should be the very middle of that segment, the location in the very center of that segment. Okay, so let's take a look at this first example, 2, 2, and 6, 2. Okay, now if I do a quick graph of this, 1, 2, 3, 4, 5, 6. Here's 2 right there, and here's 6. Okay, and so 2, 2 is approximately here, 6, 2 is approximately here, and that forms a horizontal line that's 4 units in length. And you can count that. You can count that. So if we start here on that endpoint, you see where my pencil tip is, then that's 1 unit, 2 units, 3 units, 4 units. So the whole thing is 4 units across, okay? You can see that. You can actually count it because it's a horizontal line. You can also do that with vertical lines. You cannot do that on any other kind of lines that are at an angle, okay? So if we were to find the midpoint, you could look at that and go, hey, it's 4 units long. If I split it into 2 equal pieces, then each piece would need to be 2 units in length. And this would be 2 units, and this would be 2 units. And that means that the resulting midpoint would end up residing at 4, 2. That would be the name of that midpoint. So it's real easy to visualize it when it's a horizontal line or even a vertical line. But any other line, it's going to be kind of hard to see it. And so you will want to use a formula. And so I wanted us to see the answer, using another strategy, so I can apply the formula to it and show you that it actually does match up and it works out. So to find the x of my midpoint, what I need to do is I'm going to take my endpoints, and I'm going to call that x1, and I'm going to call that x2. Okay, x2, let's rewrite that so you're not confused. And so I'm going to take 2 of the first midpoint and the 6 from the second endpoint, and I'm going to add them together and divide by 2. And so the x of my midpoint is 4. And you can see that it matches up. I'm going to do the same thing with my y's. I'm going to add my y's together and do the same thing when I divide them by 2. Okay, so that'll be 2 plus 2 divided by 2. That's 4 divided by 2, which is 2. And so that's my x of my midpoint. That's the y. And so my midpoint lies at 4, 2. Which is what I found out here. Visually, I could see that. So I wanted to do an easy one so we could apply some harder, these are not going to be horizontal. The next two are not going to be horizontal or vertical. They're going to lie at angles to each other. So, and we don't need a picture necessarily. I only did a picture to help you grasp what you were learning. You don't need a picture unless you want to draw a picture. But to find the midpoint of 5, 0 and 1, 4, and those are the endpoints, then I'm going to call this x1 and I'm going to call that x2. I'm going to have to add 5 plus 1, then divide that by 2. 5 plus 1 is 6, and 6 divided by 2 is 3. So this is the x of my midpoint. I added the x's and divided them by 2, and the resulting answer is the x of my midpoint. Now I'm going to go back and do the same thing for the y's. I'm going to go 0 plus 4, and I'm going to divide that by 2. 0 plus 4 is 4, and 4 divided by 2 is 2. And that's the y of my midpoint. So my midpoint between those two endpoints will reside at 3, 2. So hopefully you're seeing it's actually not that big of a deal. It's actually kind of simple, and you might be able to do some of this in your head. So the next 2 points, now I'm throwing in some negative numbers. Don't let the negative numbers throw you off, okay? We're gonna take our x's, we're gonna add our x's together and divide by 2. Negative 6 plus negative 2 is negative 8. Negative 8 divided by 2 is negative 4. That's the x of my midpoint, okay? I'll go back and do the same thing with my y's. I'm going to do negative 10 plus negative 8 divided by 2. Negative 10 plus negative 8 is negative 18. And negative 18 divided by 2 is negative 9. And that's the y of my midpoint. So the halfway point, the midpoint of that segment, would be negative 4, negative 9. So hopefully you're getting a little bit more acclimated to the whole midpoint concept. All right, so let's flip the page and let's look at another concept related to this. It's called calculating the missing endpoint. So instead of giving you the 2 endpoints and then you calculate the midpoint, you're going to be given an endpoint, one of the 2 endpoints, and the midpoint. And I'm going to show you how to do that. You're still going to use your basic formula. Your basic formula says, hey, if I add my x's and divide by 2, and those are x's in your endpoint, one of them you know, one of them you don't know, then you're going to set that equal. That's going to become the x of your midpoint, okay? So let me show you how to do the x's, and then the y's should become or just the y's the same way, and it should be a little bit easier, okay? Now, we're going to call this x1, and remember, this is a midpoint. That's not x2, that's the midpoint x, so that's a little different, okay? So I'm going to plug in negative 6 plus that missing x divided by 2 is equal to my midpoint x, which is 2. Okay, we're looking for that endpoint. And this x right here is the endpoint we're seeking, okay? First thing you should do is you got to get rid of that 2, that denominator. That's the first thing you should take care of. So we're going to multiply each side by 2. That'll get rid of it. And we have negative 6 plus x is equal to 4. Last step, add 6 to each side. And now you have x is 10. So the missing endpoint, this x, is the x of the endpoint that's missing, okay? Now we're going to follow the same process with the y's, okay? So we're going to go, okay, if I add my 2 y's together and divide by 2, that's going to give me my midpoint y. So what you were given was y1 and then the midpoint y. So we don't have any information to plug in for y2. y2 is my endpoint, and that's the one I don't know. So now we're going to do negative 9 plus that missing y divided by 2 is equal to negative 4. You're going to follow the same process. Get rid of the denominator, so multiply each side by 2, and now you have negative 9 plus y is equal to negative 8, and now add 9 to each side. And look what you got, y is 1. And that's that's an endpoint that you just found. So that missing endpoint is 10, 1. It's missing, that's the one. If I did the midpoint formula using negative 6, negative 9, that's one of my endpoints, and this 10, 1, then the midpoint I would calculate is 2, negative 4. So that's kind of working backwards a little bit. Let me show you this concept one more time to make sure you've got it. May have been overwhelming to see, something like this, so I don't want to overwhelm you. This is an endpoint, so we'll call it x1, y1. This is a midpoint, so we'll call this xm, ym. To just distinguish it, because there's lots of x's and y's in the formula, so we want to distinguish it. So if I add my x's and divide by 2, I will calculate the midpoint for that, okay, the x of the midpoint. So we're going to take 1 plus this unknown x, divide by 2, and that's going to equal my midpoint x. Multiply each side by 2, and I've got 1 plus x is equal to negative 4. Take away 1, and x is negative 5. So that missing endpoint is going to be negative 5, and now we've got to calculate what the y is. So we're going to do the same thing, y1 plus y2 divided by 2 equals the midpoint y. So I've got 3 plus y over 2 is equal to 5. Get rid of the denominator by multiplying each side by 2. Now I've got 3 plus y is equal to 10. Last step, take away 3 from each side. And I've got y is equal to 7. So my other missing endpoint is negative 5, 7. So there you go. That's how you find a missing endpoint. Let's say this time they gave you, on this page, they gave you the midpoint. You didn't have to calculate the midpoint because they gave it to you as well as one of your 2 endpoints. You can easily calculate the other one. Last concept here is called the distance formula. If you're on a coordinate plane and you want to know, well, how many units long is this segment? You could use the distance formula. Now, we've already talked about 2, 2, and 6, 2. That was on the front page, okay? And I want to kind of go back over this one more time. 1, 2, 3, 4, 5, 6. Okay, so we've already discussed this. I'm going to redraw the picture. If you have, let's say you've got a multiple choice test and they drew a figure for you, much like I did there, and they said, what's the distance or what's the length of this segment? If it's a horizontal line or a vertical line, you can literally count how many units it is. And we did that on the front page, and we're like, hey, that's 4 units long. You can count it if it's horizontal or vertical. Now, if it's at any other angle, you might be close, you won't be precise in the distance, and so it's going to kind of might ruin some things for you. So you'll lose accuracy, and we don't want to lose accuracy. Now, this formula is a little bit different. What you're going to do is you have this big, huge radical right here. You have a lot of math to do underneath it first. So the first thing you're going to do is you're going to subtract your x's, and then you're going to square. Okay? You'll subtract your y's and square it. And then you'll have still 2 numbers underneath, and you'll add those numbers together, and then you take the square root of that sum. So we are going to follow order of operations just a bit, okay? So this is one of those formulas, yes, you do need to memorize, okay? All right, so what I'm going to do, and you can do this in your calculator, is I'm going to insert some numbers here. I'm going to call this 0.2 and this one 0.1. And then, actually I wanted it the other way around. So forgive me, I'm going to kind of blob all that out. And I'm going to make this 0.2 and this 0.1. So I end up with 6 minus 2 in the first quantity. That's me subtracting my x's. And then in the second quantity, I'm going to subtract my 2's, which those are my y's. So you could put all of this in one line on your calculator, okay? But if it's the non-calculator part of your test, then you'll need to know how to follow order of operations. So order of operations says, do what's inside the parentheses, okay? Did it. Now order of operations says, square each number before you add. Did it. And lastly, add. Final step, what is the square root of 16? Many students are thinking that square root means take half of the number. So I get weird numbers like 8 for the square root of 16. 8 plus 8 is 16, but 8 times 8 is 64. Square root is based on multiplication. So what number times itself gives me 16? And the answer is 4. And that's how long that unit or that segment is. And we already knew that because you and I counted it on the very first page. We already knew that. So that I wanted to show you how this distance formula applies to, we already knew the answer and how it does apply to this particular problem. So we're going to go back to 5, 0, and 1, 4. We did the midpoint on the front page with those two. We're going to find the distance now of those two. So we're going to subtract our x's. So I'm going to do 5 minus 1. And I'm going to subtract my y, 0 minus 4. Okay. So order of operation, if you're using a calculator, you can put all that in one fell swoop, okay? And just put it in exactly like that. To access the square root, you'll have to hit second x squared to access the square root sign. And then don't forget to use your parentheses. Next, solve. Order of operation says do whatever's inside the parentheses. Okay, done. Then order of operation says square each of my numbers. Remember, if you're squaring a negative number, the answer is positive. If you're squaring a positive number, it's positive. And then add the two together. Now, this presents an interesting problem because this is not a perfect square like the first one was. Square root of 16 was exactly 4. There is no number times itself that will give me 32. So it's not a perfect square. But it does have a perfect square factor. So kind of think of factor trees a little bit. What number that's actually a perfect square? Perfect squares are numbers like 1, because 1 times 1 is 1. 4, because 2 times 2 is 4. 9, because 3 times 3 is 9. 16, because 4 times 4 is 16. Are you seeing the pattern here? 5 times 5, 6 times 6, 7 times 7, and so on. Okay, these are what we call perfect squares. 32 is not one of those, not on the list. But it does have a factor that is on the list. And so I'll show you how you can get there. I know that the square root of 16 times the square root of 2. I know 16 times 2 is 32. 16 is perfect. I can take the square root of 16. I know that that is 4. Can't take the square root of 2. That's going to give me a decimal. And that is the simplified version right there. Okay? We call this the exact answer because we didn't have to round the decimal to write the answer. Now, you can in your calculator do the square root of 32 and you'll get a decimal. That's what we call an approximate answer. Because when you get a decimal answer, you tend to have to round, and rounding approximates. So pay attention to any instructions you get. Sometimes they want exact answers, sometimes they want approximate answers. And they'll word it in such a way that you understand what you need to do. Okay? The last one I'm going to show you is this one. We're going to do our distance formula. And I'm just going to kind of change my strategy just a little bit. I'm going to do more of it mentally. Okay? So let's start with our x's. -6 minus a -2. Well, that's -6 plus 2. That's going to end up being -4. Okay? Plus, and then I'm going to do the same thing with the y's. -10 minus a -8. And that's going to end up being -2. So I'm going to square them, add them, And then, oh, that's not a perfect square. That number 20 is not on my perfect square list, but it does have a perfect square factor of 4 because I know that 4 times 5 is 20 and 4 is perfect. The square root of 4 is exactly 2. And I'll get 2 times the square root of 5 because the square root of 5, if you put that in your calculator, you will see that that's actually a decimal. If you did the square root of 4 in your calculator, you would see that you're going to get an exact integer answer every time. Okay, so this is the exact answer. And then if you put the square root of 20 in your calculator and pressed enter, you would get a decimal. That's what we call an approximate answer. Okay, so in class, for homework, you'll be given a worksheet where you will practice that and these skills. You're going to practice calculating the midpoint, finding the missing endpoint, and finding the distance between 2 points. And you're going to practice these skills on a worksheet. So if you have questions, you can text me, you can email me, leave me a message on YouTube, or just wait until we get to class and then you can ask your questions then. So make sure you mark down in the margin any questions you may have. Thanks for listening.